Hi, I'm Andrew Dubber. I'm the Director of Music Tech Fest, and this is the MTF podcast. On previous episodes of this podcast, I've kind of made a point, wherever possible, to sit down with guests in person and interview them. I was in Berlin to interview Daniel Haver, the CEO of Native Instruments. I interviewed Bjorn Ulvaeus from ABBA in Austin during South by Southwest last year. I've interviewed people in Sweden, Croatia, England, Scotland, the US, Germany, and New Zealand. And I really like to be face-to-face when we do this. And of course, broadly speaking, that's no longer possible in the current environment. So it's perhaps ironic that someone I've been meaning to speak with on the program for quite some time is my first Zoom call podcast interview, and she lives in the same town as me in the north of Sweden. Virginia Dignum is a globally recognized expert on artificial intelligence. She's professor at the Department of Computing Science at Umeå University, where she leads a research group on social and ethical artificial intelligence. Her recent book is called Responsible Artificial Intelligence, and it was named one of the world's best science books of 2019 by Springer. Virginia is currently working on one of the largest AI research programs in the world, funded by the Wallenberg Foundation, which I suppose is kind of like the Swedish Bill and Melinda Gates Foundation. Her part of it focuses specifically on ethical and human-centered AI. She advises to the EU, she's on the World Economic Forum Global AI Council, and she's advising to all manner of international policy bodies on matters of human-centered artificial intelligence. And what with everything that's going on in the world right now, that's kind of more important and pressing than ever. I caught up with Virginia working from home this week, and we talked about AI, what machine creativity might entail, as well as the potential copyright implications of that, what responsible AI actually means, and how she's currently using AI to help beat the global coronavirus pandemic. From just down the road, here's Virginia Dignum. Virginia Dignum, welcome to the MTF podcast. You're the Professor and Wallenberg Chair on Responsible Artificial Intelligence. What exactly does that entail?
It entails that we are looking at the development and use of artificial intelligence from the perspective of how it impacts and influences people's life, and to take into account the responsibility both of users and of developers and other stakeholders to ensure that things are done in a responsible way.
Right. So let's start with AI. How do you define exactly what AI is?
Wow, how many hours do you have for centuries?
Well, you managed to get this into one chapter of your book, so let's see if we can get this fit into a podcast.
Okay.
What's AI?
Sure, yeah. So AI is basically, so the first thing we need to understand is AI is software, is an artifact that people build. It's not magic. It's not something which happens to us. It's not something which comes out of outer space and happens. It's something which is consciously developed and engineered by people to do some purpose, which is also determined by people. So that is, I think, the most important part to understand. Then how does it work? It's what distinguishes it from other types of software is basically the capability that these techniques have to be able to analyze patterns in current situations and current contexts and use that analysis to come up with potential new suggestions or new insights. I don't really like to talk about predictions. I don't think that AI makes any predictions whatsoever. It can correlate or extrapolate from existing data, but the prediction is something that we might or not decide to do ourselves based on what AI is identifying. Again, from a more technical perspective, this type of systems are systems that are able indeed to learn or to adapt to the context by analyzing the input and the data that they receive, and they are also able to change their results based on new data. They do that, the systems, sometimes or very often in an autonomous or automatic way. So it's not autonomous in the sense of philosophical autonomy, but much more on the sense of automation. So the system doesn't need a direct user to come up with the results. And also, importantly, the system interacts with us people in different ways. And that makes that the system, the AI itself, the way that I like to look at it, is not only the technical components, but also the social technical environment in which we use the system. So when we talk about responsible AI, it's not that I want to give the software the responsibility for its results, but more that I want to ensure that there is a social technical context or an institutions around the software which are able to take the responsibility for what the system does or doesn't do.
So let's start with this idea of responsible. Responsible by what measure? Who gets to decide what's responsible?
That's a very good question, and indeed it's one of the things which we work on. It is, let's say, it's kind of responsible in the eyes of the beholder. So if users need to see responsibility for what the impact, potential impact and potential results are of the systems, then it's up to developers and policymakers to ensure that that responsibility is somewhere, that there is somewhere where we can go in terms of liability, that there is somewhere which can be accountable for what the systems happen. It also means that we need to take into account that it is important to have some level of transparency about what the system is doing. And there again we can understand transparency at many different ways. But basically, at very minimum, we need to have some openness about who is developing this system, why is this system being developed, why am I interacting with this system, what kind of potential impact the system can have in my own life, and where can I go if I have any issues which I would like to discuss about the system.
So from my understanding of something like machine learning, you give something a lot of case, like the example that's always given is photographs of cats.
Yeah.
And you give lots and lots of photographs of cats, and you say these ones have cats, these ones don't. And then the AI system will then later be able to identify photographs of cats. But my understanding is that it won't necessarily be easily able to tell you why it thinks that there's a photograph of cats in there. So does the idea of transparency in decision making actually hamper the possibility or restrict the possibility of what might be possible with AI? Is it a problem to try and make these decisions transparent, if make it explainable?
No, I don't think so. Indeed, the example of the cats is the same, is the example that is usually given. First thing here, we have to understand that the AI system, the machine learning, has no idea what a cat is. Even after I've seen 20 million pictures of a cat, it will never be able to tell you that the cat is some animal which meows and doesn't bark. It's not able to tell you that that thing eats or that thing sleeps. So it has no idea of what a cat is. It just is able to understand some set of characteristics of those pictures, which it then tags as being a cat. Often the example which is given as a counterexample to this is that you can train machine learning to identify wolves in pictures, and the distinguished factor of those pictures is the amount of white pixels. Somehow pictures we have of wolves are in the snow, and then the machine learns to identify that a lot of snow in a picture, it's more likely to be a wolf than to be a dog.
Wow. Okay. I would not have thought of that.
Even worse than that is we can train machines, and we use machines more importantly than for cats and dogs and wolves to identify, for instance, cancer cells. And one specific example which has been given is that when the doctors suspect that someone has cancer, they are more likely to make a better resolution type of scans than if it's just a normal scan. So they use different types of machines. The machine learning algorithm learns to identify some characteristics on the picture, things like scales or dots or some kind of things which have nothing to do with the image of the cancer cell itself, but with the formatting of the pictures, and then associate the ones which have the higher resolution with the higher probability of having cancer. That's where responsibility starts. We are training machines on data. We not always know exactly what are the patterns that the machine learning algorithm is identifying as being whatever we want it to be, cancer cells or dogs or cats or whatever. And then we are relying our own decisions on the results from these machines.
It sounds like what you're describing is not so much artificial intelligence in the sense of abdicating decision-making process to a machine, but some sort of enhanced intelligence for humans, a tool for adding to how we can make our own decisions.
Yes, and I do think that the better solution is to have a combination of machine intelligence and human intelligence. Machines are great on identifying whatever pixels we need them to identifying in a way that they never get tired, they never make mistakes, they will do the things always again and again in the same way. Like I say, they don't understand what's a cat. We do understand what's a cat, but we are not very good at being consistent and tirelessly looking at cats on the internet. So if we combine both things, we get the best of the two worlds.
And likewise, I guess, from a medical perspective, I mean, you've been tracking policy responses to the coronavirus using artificial intelligence.
Yes.
Can you tell me a little bit about that?
Yes. So what we have been looking at, it is what we realize is that at this moment, data that is available about coronavirus is extremely unreliable. Firstly, the most data that we have is the true positives, is the people who have been tested and positively been tested of having corona. That is the only part of the data that we can trust. We know a little bit of people who have been tested negatively. So we know the correct cases. We don't know the people we didn't test. And we don't know in many cases how accurate and how well performed these tests have been. So there is a huge difference in data about coronavirus epidemics from the different parts of the world, and also in terms of quality of this data. So our approach is, okay, if that is the case, let's see if we can understand the policies that different governments are doing in terms of other types of features. So we are looking at demographics, we are looking at economic effects, we are looking at things like what would be the impact of, for instance, doing 100% testing. It's not really possible. No country in the world has the capability to do 100% testing, but we can, in a simulated environment, identify what would be the difference between 100%, 80%, or 60%. And then we can support governments to tell them, okay, the difference between 60 and 80% is maybe not so big. That entails the needs and the expense and the costs of doing the extra 20%. We are also looking at what is, for instance, the effect of closing schools. And things which we are seeing it's a simulation, so it's based on synthetic people. Let's say we create a bunch of fake agents which behave more or less like people, let's say. We put them all in a city of, I think our city at this moment has 5,000 inhabitants. They all have their own types of jobs, their own types of families, which we can, of course, play with it and change that as we go, like in SimCity. And then we see what is the effects of closing schools. One thing which can see, depending on the demographics, is that people will put the children with their grandparents while they go work, which is probably not what we want, because we want to isolate the elderly population. Another thing we see is that if people are at home, stuck at home working with the children and doing their own work at home, they will take any opportunity that they can have to go outside, like in the weekends. And then in the weekends, they will go to places where they are more likely to encounter other people which are not normally in their own circles. Because this idea that everybody can contagious everybody else, it's in theory true, but in a sense we all live in very small world communities. So we usually in a day, if you and me live in Umeå, but in a normal life we don't encounter each other, because you are in your own circle and I'm in my own circle. So at a certain moment within those circles, you don't really contagion more than the people which is there. If we go out of those circles, which we see that increases in the cases where people are forced to be contained for quite some time, I'm not saying that these are real effects, but it's potential effects which need to be taken into account when the policies are being made.
If policies are made based on your kind of SimCity simulations of how people should behave, and it turns out that people don't behave like that, whose fault is that?
That's the fault of everybody who took the decision of making that policy. I'm not saying that we should make policies based on my SimCity. What we want with our SimCity, if we want to call it like that, is to provide a playground to experiment with many, many, many different policies. So I would not really agree that it is used to test one policy and see, it says that people go put the kids at grandparents, or it says they don't put the kids up to grandparents. Mm-hmm. But really you need to try a few hundred different types of approaches, not so much to know what is the result. I don't think the result is what is important, but by doing it, you start getting insights yourself about potential effects.
Right.
And that is where I think the policymakers need to take the decisions for the policies that they are making.
It sounds like what you're doing is very humanities, social sciences, cultural studies, but from within a computer science department. How interdisciplinary can you be?
Yeah, indeed, that's what I do. Have a background in computer science and mathematics myself. I have been working in a very mixed discipline world for a long time. Half of my life I worked in industry and in consultancy and development, and half of my professional life I've been working in academia. And in both cases I have been working always in very multidisciplinary environments. And like I say in the beginning, AI is not only the technology. AI is the people, is the humanities, is the social science, is the interaction between all these things. It's not just about engineering systems because we can engineer them. It's about engineering systems because we can have some kind of positive impact on society. And this type of understanding what is the impact in society is not something which we usually do as engineers, but it's exactly what humanities and the social science. And that is why I'm very happy and honored to be leading this initiative from the Wallenberg Foundations on AI, autonomous systems, humanities and society.
So what actually is the Wallenberg Foundation's interest in AI?
As far as I understand, and I cannot speak for the Wallenberg Foundations, I'm just a researcher. A few years ago, they realized that the benefit, and they work always very much from improving and being beneficial for Swedish society and Swedish industries. They realized a few years ago that Sweden would need to do a step forward on AI research in order to be able to keep up with the demands from Swedish industry and Swedish society. So they have created this WASP program, which is actually the reason I'm in Umeå now, is because I was approached and employed by the funds that were made available for universities to attract AI researchers to Sweden. Mm-hmm. So they created this WASP program, which by now it's one of the largest ever programs in the world on AI funds. And recently, so 1 year ago, they realized exactly, or they continue on this, that it's not just about providing the technology and the computer science research on AI, but that once we want AI to be beneficial for Swedish life and Swedish industry, we also have to understand what is the impact. And for that, they create this new program, which started last year, which is exactly about analyzing the impact. And it's a program focusing on the social science and the humanities research.
One of the things that sort of struck me as really interesting about how at least your work is described online is that part of your research is about the formalization of social interaction. Can you unpack that a little bit for me? The bit that I'm sort of stuck on is the idea that social interaction can be formalized.
I don't think social interaction can be formalized, but if we are building systems, again, engineering artifacts that are going to interact with us in our social context, we need to design those systems to be able to do that in a way that it fits with the way that we live and that we interact. And for that, we need to, and the systems are at the core formal mathematical functions because it's software. We have to build it to to work. Otherwise, if we cannot make a function of how the things work, we cannot build the software. So we do need to have somehow ways to formalize social concepts such that we can build these systems that can interact with us. It's, of course, like any other formalization or any other engineering thing, an approximation of reality, and it's not to formalize our interactions, definitely not, but is to build these systems. So one of the things we are looking at the moment is this notion that we want AI systems to be fair or to be bias-free. What do we mean by fairness?
Yeah.
And what is the mathematical function that guarantees me that the system is fair?
Because mostly people say that they want things to be fair, but what they mean is they want them to be more unfair in their favor.
Yeah, they want the things to be fair for you, yes.
Yeah. So again, the question comes back to who gets to decide what's fair.
Yes, so our approach to that is that, in a sense, we don't care. You give us a definition of fair, and we try to build the system which meets your definition. So that's the easy, let's say, me, the engineer speaking, but me, the more multidisciplinary person speaking, would say that in order to get a notion of fair that really fits the context in which we want it to be fair, you need to take a participatory approach. You need to look at all the different potential stakeholders in your system, the users, the developers, the policymakers, the society in general, the ones which might be indirectly affected by it, and try with them. And there are techniques, again, from the social science and from humanities, which enable people to agree on a certain way of, a certain definition of fairness, which is definitely not yours or mine, but it's something which both of us are sufficiently confident. We do that in many other types of social systems. We do that on democratic process and elections. We take the result of a democratic election as when we accept it, even though it is usually not the result that no individual in him or herself was expecting.
I think it's also been a long time since anybody described a democratic election as fair. So it's
okay. That was not the definition I want to make. It was more about the process.
Sure.
We accept the process of democratic elections.
You accept the outcome.
And we take the results. We accept the outcome, and we work from the premise that that outcome is the outcome which is the most beneficial for all of us. So that process is the process which can be taken in order, for instance, to understand what would be the outcome of fairness for a certain AI system.
Sure. We spoke to Charles S., who is an ethics professor, and he's obviously very interested in the ethics of AI. What's the overlap between what somebody like he does and what somebody like you do?
I think that we come from different backgrounds and different sides of the spectrum, but in a sense we are looking about not so much the ethics of the system itself, but about how much does the system interact and influence our own ethics. And there is all these examples, and you probably have read about it, on teaching AI systems to be ethical, or all those trolley problem kind of things, whether the self-driving car should kill an old lady to one side or two small kids to the other side, and all those kind of things.
Sure.
And in a sense, and I think that Charles S. agrees with that, that's not the most interesting problems. The most interesting problems is how is AI and the use of AI interacting with our own sense of morality and ethics, and is that going to change as we use, and our interactions are more mediated by AI type of systems? Right.
The two main AI professors that we've dealt with in our labs at MTF have been Danica Kragic in Stockholm at KTH, and Amy Lutfi in Örebro, and now obviously we're speaking with you. Is there something that you think that women are particularly good at when it comes to this topic?
I don't know. AI is a very male-dominated field, especially the more mathematical and computer science part of it. You do see much more women working on the societal aspects of AI than in other areas of AI. It's not that there are no men at all working on the social aspects. I don't really know if it's a more female type of thing, but in a sense, I think that I never like to make this type of generalizations, but women tend to be more broad, approaching things in a broader way, and men tend to be more specialized in a specific problem. And maybe these societal aspects are things which need to be taken in a more broader way than a very focused and specialized approach. I wouldn't dare to say it's a male-female type of thing.
In a broader way, meaning?
Taking more things into account, taking the broader picture into account and not so much the specific details.
Okay. I'm interested in your journey because you're a long way from Portugal and you've been in Delft, obviously. What's your journey? Where did this start and how did you come to be where you are?
Oh, it started in Portugal, indeed. I'm born and raised in Portugal. I studied in Portugal. I studied mathematics and computer science. When I studied in the 80s, we didn't have in Portugal a specific computer science degree. So I did most of my degree in the mathematics and then specialized where I could in computer science. Already at that time, I was working on very interested in AI systems, and like I say, the very first AI programs that I developed is already in 1986, so it's very, very long time ago. At that time, we were much more trying to understand how to represent human knowledge in a machine understandable way, which is a very different way from the approach that we are now looking at AI to do it from a data-driven type of way. But still, both of them are very much main tracks within the AI discipline. I moved to the Netherlands for a combination of studies and love. My husband is Dutch, so it was a good combination. From the Netherlands, after I finished my studies there, master's on AI in the Free University, we moved quite a lot around the world. We worked in Swaziland. We developed there, implemented the very first computer science degree at the University of Swaziland, which is a small country in Africa. It's called Eswatini nowadays, but near South Africa. We have been for 1 year in Australia, and now since 1.5 years I'm here in Sweden. Mm-hmm. Like I said, I both have been working in industry and in academia, so I've done a lot of different things, which in a sense makes it easier to move and to do other things more than if you had been working all the time in the same place and in the same topic, I think. Mm-hmm. And I was very happy and very excited to come to Sweden, and not only for the possibilities that we got as Wallenberg chairs here at Umeå University, but also now with the possibility to really shape this new area of research on the AI, humanities and social science, which I do believe that it's kind of the direction that we have to take forward in the use and in the development of AI systems. Right. It's not to go to yet another improvement on the machine learning algorithms, but it's much more about how we take it again in the broader perspective and take the broader picture of impact and technique together.
Right. And now, of course, you're advising at the highest levels of policy. I mean, like Michaela Magus from MTF, advising the European Commission on things like AI. Yeah. But you're also now part of the World Economic Forum Global AI Council. What does that do exactly?
Basically, the World Economic Forum AI Council advises the World Economic Forum bodies on AI issues. And they also, as a council, are working on specific white papers or specific briefs on issues related with AI. So at this moment, like a lot of other people are working on the contributions and not only the contributions, but the effect that the COVID-19 situation is having, especially on data, on surveillance and on controlling of people and populations. So we are looking about seeing whether we should be saying and reflecting on that, and how can we best advise the World Economic Forum on those type of issues. So we try to be one step ahead of what the policymakers would want to know, to have something to provide to them.
So you have answers already?
We don't really have answers on that one, but we are quite, let's say, concerned or looking closely to the fact that increasingly a lot of countries are opening and relaxing their regulations concerning data collection and data usage and tracking of people and surveillance because of the crisis, which we fully can understand that is something which might be needed now. But the point is, once the genie is out of the bottle, can we put it back in the bottle once the situation goes back to some type of normal?
Sure.
And that's the things which we are trying to discuss at the moment.
Obviously, our community is really interested in the overlap between creativity and AI, and the idea of, say, for instance, who owns something if an AI creates a piece of music. How do you think about these sorts of problems?
If you realize my view on AI, that it is an artifact, a tool, then the creativity is with the people. It's with the ones which develop it, the ones which employ it in a creative way, the ones which provide the facilities for the AI to generate some type of music or art or whatever. I've been working or talking quite a lot with a researcher at KTH, Bob Stern, who does machine-generated music.
Yeah, folk music.
And I would say that if anything, it's him and his team who are the creative ones. Because they are the ones who think up the ways that AI could be created. AI is the tool.
So what do you think are the biggest opportunities for AI right now?
The biggest opportunities for AI is the possibility to enhance human intelligence and for us to make us do things in a better way and to take into account the differences and the societal impact or the societal possibilities of what we are doing.
And dangers?
It's the same. It's how we are using AI to influence and to enhance our own capabilities. We are extremely creative on good and on bad kind of things. So AI can only enhance our capabilities for bad and for good.
And are you optimistic about that?
Yeah, I'm an optimistic person. So I think that at the end, it's, in a sense, one of my colleagues always says that there is no business model for unethical AI or for an irresponsible AI. So in a sense, even if we take a very business market-oriented approach, the main opportunities are on the responsibility and the trustworthiness of the systems we are building.
Wonderful. That sounds like a really positive place to leave it. Virginia, thanks so much for your time today.
Thank you.
Really good to talk.
Thank you for talking. It was nice.
Thank you. I appreciate that. That's my neighbour, or near enough, Virginia Dignum, Professor at Umeå University, Wallenberg Chair on Responsible Artificial Intelligence, member of the EU's high-level expert group on AI, and Scientific Director of the WASP AI Research Project in Humanities and Society. And that's the MTF podcast. You can follow Virginia on Twitter. She's at VDignum, that's VDIGNUM, and she links from there to all manner of interesting things that she's working on. I'm Dubber, at Dubber on Twitter. Music Tech Fest is at Music Tech Fest, pretty much everywhere. And of course, you can share, like, rate, and review this podcast. If you find yourself with a little bit of extra time, you can go back through and listen to older episodes, something like 60 hours worth if you do it all back to back, but why would you? And this will be back next Friday with more of the interesting people from the worlds of music, technology, innovation, creativity, arts, science, academia, and industry. Stay safe, wash your hands again, and we'll talk soon. Cheers.